Hello YouTube, RJ. Hey, got a couple packages on the bench, a couple things came in. Thought we'd take a quick look at what we got come in. And maybe we would build one of them, because I believe one is a kit I'm expecting. So let's see what we got. What is this one? It's going to be an AliExpress orders. Okay, I know what these are, I believe. So let's take a peek. So that's going to be the kit right there. What did I get? What did RJ buy now? Well, let's take a look here. Well, RJ bought a couple of multi-position rotary switches. So part of my radio kit design, got those in to try to work them into the Lynx Easy shortwave receiver we're working on. And this is also parts for that. Yep, that's some chips I ordered, some 8831 AP chips that I ordered. Trying to get it ready to unveil and show you the finished what I'm doing and move forward with that. A lot of work involved. And you know, this isn't a full-time job for me. This is a hobby, and you know, with the holidays and maintaining the house and all the things that all of you have to do and deal with, I'm sure you understand that sometimes it takes a little while to pull these things together, especially something with as much moving wheels as what I'm working on. I want to get this thing right. I don't want to start showing things that aren't going to be the way they are. So I'm working on that. Trust me, it's coming. I had somebody email me a question why I keep talking about this receiver, but I don't show anything. It's because I'm not quite ready to. When I get it to where I'm happy and can get finished stuff in here to show you, I'm going to show you, and it's going to be one of those slowly at first and then all of a sudden everything. So this is kind of part of that, actually. This is a kit I ordered, and if you've done shortwave listening or ham radio stuff or whatever in the past, you probably realize that you really improve your reception. Not just, you know, people have antenna tuners to match their transmitters to low SWR for transmitting. But the other side of that is when you're just receiving, a lot of people believe you don't need an antenna tuner for receiving. And while it's true, nothing's going to get harmed. Anyone that's played with shortwave receiving or receiving with the receivers that are using a fixed antenna that tried a antenna tuner knows that when you peak your antenna with an antenna tuner, it really helps your reception. And so my thought is, if I can add very inexpensive components into the Easy shortwave receiver and give us a little front end antenna matcher to allow us to match to whatever antenna you're using to optimize it for the frequency you're listening to and really pull in weak signals, then why wouldn't I do that? Radios over the years, there's been, you know, peakers, they called them sometimes. They had different names for them that basically tuned the front end of the receiver to the antenna and allowed you to pick up better signals. Well, I want to do that. I want to build a really neat, well-performing, super simple, inexpensive shortwave receiver kit. So that's where I'm going. So what I did was, I'd seen many of these little antenna tuner kits, inexpensive, and I thought, you know, I'm gonna go ahead and just buy one and look at what they're doing and try it out with the radio. Oh, that's in there pretty tight. Try it out with the radio receiver, and then see how well it works and how much it helps. And if I like it, then what we'll do is we'll design a similar circuit, if not identical circuit, into the Easy shortwave receiver. So I ordered this on Amazon. I'll put a link, as always, in the description. And it's got everything you need, supposedly, including the enclosure. This was $15. So it's not a very expensive kit. And it allows you to build a little mini QRP type antenna tuner, which will handle far more power than we need. I can't remember what it was, 15 watts or whatever. We're not going to put any watts. We're going to receive with it. So my thought is I could look at this take hints from it, you know, build this, hook it up and try it with it, see how it works. And if I like how it works and I like the benefits I get from it, then I'll design this in. So this is the kit we're going to build today. See what we got. We got a sticker for the front of the box. I don't see any instructions for putting this together, which I guess that doesn't surprise me for a $15 kit, but let me take a minute and do some research and see if I can find instructions online. It would be very helpful to how many windings do you put where, that kind of thing. So see you in a few minutes. All right, we're back. Boy, did I go down a rabbit hole with this thing. I got online, started researching, had a hard time finding any information. They don't ship instructions with this thing. I found some online. I actually found a PDF really nice of a guy building it. Went in great details. I mean, the thing's probably 20 pages long, talking about theories of operation and, you know, his experiences and such. But ultimately what was interesting was, as I was looking through all of this, I found I copied only the pages that I need. If you research, one of the things you're going to come across is this right here. This is supposedly the diagram. Now, this circuit right here, from these two connections of the switch down, is all an SW, a little LED. Basically, all it does is when you're tuning, it lets you see the light glow brighter or dimmer to tell you what the SWR is while you're transmitting. For what I'm doing, I don't need this nor want this. And so basically the circuit board, where did the circuit board even go? Here it is. The circuit board is, I don't need the circuit board. I have no need for it. So I'm not going to be using that. So all we're really dealing with is this part right here. Input, we won't be using the switches directly through, straight through the variable capacitors. So the output with a tapped coil and a switch. But what I've got to tell you is, as I researched a little more, I found some important information out. This little insert here telling you how to make this, how many windings, is wrong. It's not correct. People build these and then they find out that it works at your higher frequencies, but you can't tune lower frequencies. And the reason for that is this is backwards. This is not the way it's supposed to be. This turns out to be the way it's supposed to be wired. And you say, well, what's the difference? Well, when you look, let me bring this one back up here. When you look at this one, you'll notice that there's a lot of turns before you hit your first tap. And then you have all these taps. In reality, what you should have is you should be having the very small amount of inductance switching at the very beginning for your higher frequencies. And those long 10 turn tap should be at your very low frequency. And so what happens is you can't get enough inductance to get low frequency. This setup works correctly. This is what you want to do. Here's a picture, and my printer I think needs to have some toner changed or something. It's having a little problem there. I decided to have a conniption fit on me, but here's somebody's picture of how they build it. And what happens is you parallel these capacitors together. So there's two sets of there's two capacitors in here. And what you do is these bend up so I can get them like they are in the picture. And what you do is you bring your input to the middle, and on this side, the middle goes to the output, and then you tie these two together to parallel those capacitance to get a larger capacitive range. And those tie over to the other capacitor the same way. So that's why he's running this together, running over here, running over here. You're connecting that as one run. That's connecting the capacitors together here. That's what you're doing. And then he takes off of one of these center pins. One of the center pins, he brings it down to, I'm sorry, not the center pin, I'm sorry, one of the side pins here, he actually is from this side, he comes into his inductor, and of course this is how we want to wire it here. So the center pin's here, and then your two outers hook together and run over two outers hook. So he's connecting to the outers between them and coming down to ground. So we're going to do that, and that's all the circuit's going to be. It's going to be the two varied capacitors, the toroid, and the switch. is all that's going to be in mine. Of course, we'll have the BNC connectors also in there. The other thing I ran into in this rabbit hole of studying this thing is, this is the wire they send you. This is not the wire they describe that they sent you. They tell you they sent you much smaller wire than this. And you say, well, what does that matter? Well, why it matters is because this wire is so hard to work with to do what you're doing here, because you wind these, and every so many taps you tap off the coil, or so many windings you tap off, and that solders onto this pin. And it's kind of a pain to work with from what I understand. And I'm going to measure, make sure, but they were talking about the two sizes of wire, what they say that comes with the kit and what they actually been sending. And so I'm going to check and make sure this is the wrong size. If it is the larger size, I think I'm going to go with this 27. The only negative is if you get too light, when you put this together, this thing won't have a physical connection to keep it stable. Let me get the mic and measure this. I'll be right back and we'll see what size it is. Okay, I went and got my calipers, and what they're saying is they claim they sent you 0.5 millimeter wire, and that's what you're supposed to be using. But everybody says they send you 0.8, which is really hard to work with to do this. And so I thought I'd check and make sure I'm not mistaken. Oh yeah, I don't know if you can see that, 0.8887 millimeters. So that's definitely thicker than what the kit is supposed to come with. So I pulled out my box of wire and inductor wire and all that, and I have some 27. I've got some different sizes. I picked 27 thinking it was probably pretty close to 0.5. So let's see where we are with this 27 gauge. And it's measuring a little small. Okay, let me see, grab the box out here. And we've got plenty more to choose from. So let's put this back, this 27, and let's see if we can find something a little closer to 0.5. Here's some 25. Let's take a look at this 25. It'll be bigger than that 27. See what we get. .60, 0.59, a little bit bigger. That's going to be probably the closest I have. We are going to go with some 25 gauge. It's going to be much closer. So I'm going to go ahead and set up to wind this. I don't know if I'm going to time lapse it or not. I'll make that decision after I see what it looks like in the edit. So either you're going to see a time lapse or you're going to see me come back in a few minutes with some work done. So let me get started. And with that, we've got our inductor made up on our switch. That's the major job right there. That was about an hour and 15 minutes for me to do that. For the easy shortwave receiver, I think that's a little too much work than I want to have you guys do to build this thing. And I think I know how I can build this so much easier in the kit. So I'm going to work on that. So let me finish drilling some holes, mounting this, getting it wired up. We'll test this thing. We'll put it on the Nano VNA and see if it looks like it's working. So I'll be back. Okay, and I'm back. And if you're very observant, you might have noticed that my shirt changed. That's because I had a little break in between the last video clip and this one. It's actually the next day. And the reason for that is I was working in the evening and intended to get the video done and run into a little problem. Just as I ended the video last time, I heard quite a scream in the other end of my house. So I had to jump up and run and see what was wrong. And I live in kind of a rural area, as most of you that of my viewers know. And my wife had stepped on a small snake in our bedroom. And as you can imagine, that took priority over finishing this video. So I spent a few hours the rest of the evening tearing everything out of her bedroom because that sucker had found somewhere to hide. She'd scared him. He run and hid. You know, there was going to be no sleeping in my house until that snake was found and he was evicted. So it was quite the ordeal. And finally I did find him, and finally I did get him out of here and took him out into the woods and got rid of him. Anyway, that put an end on my video and for the evening. So I got back in the next day and finished up as I said I would. And so now we're going to take a look at where we are and what we got going on. Okay, so here we are. I got a lot of parts left over because we didn't do the circuit board. Remember, we as I explained, I'm not going to build any of this because this is nothing more than a testing device for me to see if I like this T-type antenna tuner and if it was going to work for me. If it worked well for my shortwave receiver, the EZSW receiver we're building, then basically what I'm going to do is I'm going to incorporate this design into the shortwave, easy shortwave receiver. But what I'll do is, this was such a pain to build, I've got to tell you. First of all, after you last saw me, I come to realize that I had got all the connections to the switch turned off one pin. So I had to desolder it and resolder it. Well, in the process of resoldering it, heating it over and over again, this switch didn't like that too much. One of the pins kind of melted the plastic around it, and the switch has a problem now. I can't use every connection in it, but most of them. So it's good enough to do a test. So what you're seeing here is, if you look at the, let me make sure I've got you set up here good. Let's jump up here. Forget the switches here. Just imagine this input going straight through this capacitor, through this capacitor. That is coming in here to this capacitor. And then coming out of that capacitor, we parallel the two sections of the capacitor to get the maximum capacitance out of this rascal. And then we have another line that runs over and into this capacitor, paralleled, out of that capacitor, out the output. So, or vice versa. Actually, I've got this upside down, so it's coming in here, going through, and going out. The truth is it's marked, but the actual truth is this doesn't care. It'll work both ways because, I mean, if you think about it, it's just a parallel. I mean, it's just a mirror image. You got two capacitors, same capacitors, and your inductor in the middle. So whether your signal's coming in this way or going that way, the only difference is if you were trying to, write down where to put things at the capacitors to be correct, you would always need to be connected the same way for that to work next time. But it doesn't really matter which way it goes. So anyway, in through the capacitor, passed on through the capacitor and out, and then teed off right here, if you can make this out, into our inductor is this connection, which is teed right in the middle of these two capacitors, right here, teed off, comes into the side where we have one turn before the first tap, and which is important. We don't want this in backwards. And then off here on this end, where you have the 10 turns, it comes off and connects, make sure you can see good, connects right here to this copper wire. Also, the switch, the tap of the switch right here comes out and connects to this wire. What this is the ground. We pass the ground from one side, actually coming in here. We pass the ground through copper wire straight to this connector, and then we tap this end of our inductor and the center connection of the switch to here, and voila, we're done. That's it. So the question now is, does it work? Well, as I said, I've got a little problem with the switch. I can go A through H. So I, J, K, and L is out of the picture. So let's hook it up and find out what happens. Now, I guess what I'll do is, before I do that, I'll go ahead and put the bottom on so that nothing's touching or getting, we don't get any interference of any kind. So let me get the screws in this. I'll come right back. I promise this time, barring any snake attacks. And we'll hook it up to the VNA. I'll get it VNA set up, and we'll see if it can push around the tuning of an antenna. So be right back. All right, so I got the VNA set up. I've calibrated it. I've taken my external ham antenna, hooked up to it. Want to see if we can push the tuning of that antenna around with this rascal. So I've got the VNA Saver software fired up here. We're doing a continuous scan from 1 to 30 megs. So I'm just going to make some changes here and see what happens. Well, we can see it's moving. Definitely can move it around. Oh yeah. Oh yeah, it's definitely doing tuning. Now that's on one inductor setting, so I can definitely push it around there. Let's change the inductor setting. That definitely made a change. We can definitely tune around. I would say it's working. Yeah, I'd say it's working the same as my big T tuner, home build kilowatt tuner that I built. Just a miniature version of it. Yeah, I don't see any reason this wouldn't work for us. So does it work? Yes. Could it do with some improvements? Absolutely. Some shielding to keep capacitive coupling from being a problem would be a big help. Does it work? Yes. Is it a great build? It's very difficult to wind that coil because you have to put loops on it to solder to the switch. It's very hard then to clean off the wire to make it solderable without unwinding some of your windings in the process. It's not the easiest thing to do to wind that and get it put on there. It took me, as I said, hour and a half. Then I had to take it off and move it because that was my stupidity, but I somehow managed to get it off one pin when I was doing it. So I had some thoughts how we could improve this and do better on the radio. On the radio, my intent is, what if we were to take and build it to where you took the toroid, you put the switch in first, okay, and then the toroid windings on the outside are a little bigger than the switch. So what if you took and did a circuit board where the switch just went in and soldered, and then your toroid on the outside of that switch, you had through holes so that you could literally take your toroid and make a winding, where you say you have two windings. You go two windings, you stick the wire through, one wire through, and solder it. Two windings through a hole in the board and solder it. Then you start at the next hole and you go through and maybe you do four windings if that's what's required and solder it. I think this would be so much easier. It'd allow you to clean the enamel off the wire real well. In fact, I'm thinking if we do a kit and we kit that part of it, I'm going to see if I can get some of the wire where the solder itself will burn the enamel off. That's going to make life so much easier. So I think that's a lot easier way to do it. So I think that's kind of what we're going to do. And of course, these poly variable capacitors, they'll solder to the board, and that'll make that easier. And all the traces will do all your connection. You won't have to run wires, jumper. So I think we can do it. I think we can do it. You can see how small we could make it. I think we can make this work for the radio, and I think it's going to work very well to help peak signals out. What do I think of the kit? For the money you pay, the parts would probably cost you more to get them all, but it's kind of a shoddy setup. The knobs here don't fit the variable capacitors. It's just some screws, and then they have you put like a nut through with a washer, and they don't give you instructions telling you this. You have to research it online to find this. And then what happens is when you turn one way, since you're tightening the screw, it works well, but when you try to back off, the screw backs off. So what I ended up doing is, I've read everything from putting lock washers on there. What I did is I just took some Stick some of my gel super glue that I use when I'm doing the Manhattan building, and I just slobbered some on there, screwed it in, and let it harden up so that the screw would hold. Everything about it is just a assortment of the cheapest parts they could find. You know, there's ways to do this, and in fact, on our radio, as far as trying to do a knob like this, I'm not going to do that. There's a solution for this. They make a little adapter that goes on there that lets you put a regular knob on and tighten it up. That's how we'll go. We'll actually put regular knobs on that actually don't have to have the tops taken off and screws showing. I mean, I'll try to make it nice. I'm going to end it here. Hey, thank you for hanging out and watching this. I hope you learned something. Hope it was a little bit entertaining, and I definitely hope you'll hit that subscribe button if you haven't, and please hit the like button if you enjoyed any part of this video. And more important than that, I hope to see you in the next video.